All right, everybody. So here is just how to approach the challenge problems for 1.07. Because these are hard, these are challenging. The other problems I kind of scaffolded for you, so I had you solve it one part at a time. These problems, I just give you all the information and ask you to find the entire answer without any scaffolding, without any intermediate steps. All right, so number 11. I'm not going to solve the whole problem with you, just walk you through how to set it up and what to look for. Number 11, a student throws a crumpled paper ball into the recycle bin. All right, so Mr. P has to do push ups from a perfectly horizontal angle. The bin is 7.61 meters away from the student. When thrown, the paper ball lands perfectly in the recycle after being in the air for 0.85 seconds. What is the velocity of the ball as it hits the bottom of the recycling bin? All right, so as we do this, um, we'll just make sure that we keep track of all of our variables, right? So we're still using this guess method. We're still writing down everything that we everything that we need to figure out. So on this guess method, all right, givens in the x-axis versus the y-axis. Okay, let's draw this just to help us out here. Okay, here's our crumpled up paper ball. We need to throw it perfectly horizontally and into the recycle bin. All right, the bin is 7.61 meters away from the student. So 7.61 meters. All right, after being in the air for 0.85 seconds. All right, so we know that time, 0.85 seconds, time, 0.85 seconds. What is the velocity of the ball as it hits the bottom? Okay, so that's our unknown. We're not quite to that yet. This 7.61 meters down here, which variable is that going to be? All right, well, that is going to be our distance traveled in the x-axis, so 7.61 meters, because it's left to right as opposed to up and down. All right, there's a couple other variables we know simply based on the fact that it's a horizontal angle and we're on the planet that we're on. So at a horizontal angle, we know that the velocity initial in the y-axis is going to be equal to 0 meters per second, because just at the beginning, the velocity is completely horizontal. There is no up and down component. So that means that initially it's at 0 meters per second in the y-axis. All right. The other thing we know is our acceleration, negative 10 meters per second. If you want to call down positive, sure, go for it. But I'm going to call up positive and I'm going to call right positive for pretty much all horizontal projectile problems. All right. What is the velocity of the ball as it hits the bottom of the recycling bin? Okay, so truly our unknown here, terrible handwriting, but you know what I'm going for, is velocity final. Well, for our velocity final, we have to do a little bit of extra work here. Right, there's the velocity in the x-axis, there's v final in the x-axis. But is it truly v final, or is it just velocity in the x-axis? Because there's no acceleration in the x-axis. So I'll just call it vx. And then here we have v final y. This is truly v final in the y-axis because we have an initial and we have a final. So what we need to do is we need to find just the velocity final, and that will be with Pythagorean theorem, right? So vx squared plus vy, oh, there's my undo button, plus v final y squared equals velocity final squared. So you are going to have to use this to find v final. But what this also means is we need to find velocity in the x and we need to find velocity final in the y. All right, well, velocity in the x, velocity final y. Okay, so when we break this down into our different axes here, our x-axis and our y-axis, we can see something kind of neat. We can see, okay, in the x-axis we have time, we have displacement, and we have velocity in the x-axis. All right, well, what's the definition of velocity? Definition of velocity, distance over time. All right, that seems pretty straightforward. In the y-axis, slightly less straightforward, but we need v initial, v final, a, and t. We can find that. There's an equation that relates those four variables. I'll let you go through and find that and figure it out. So that's how you approach number 11. All right, number 12. Number 12, a llama spits horizontally at I to B soaked and catches her at her feet. All right, I just like to draw these situations here. So we've got a llama. I'm not the best artiste in the world, as you probably figured out. Llama's got those big ears. Definitely doesn't look like a llama, but we've got to give it a little tail. All right, happy llama. Okay, a llama spits horizontally at Ida be soaked and catches her at her feet. Okay, so Ida's over here. Ida's getting spat at, so she's not very happy. All right, so this little wad of spit spits horizontally and gets right on Ida's feet there. All right, the llama's mouth is 2.19 meters off the ground. So 2.19 meters off the ground. And the llama spits with a velocity. I'll use a different color for velocity. The llama spits with a velocity. So velocity initial of 6.37 meters per second. What is the angle above the ground that the llama's spit hits Ida's foot? All right, so we're looking for, when we make this triangle here, we're looking for what is this angle? All right, so our unknown, theta equals question mark. All right, but when we do this, we're going to have to make our triangle here. The triangles relate what quantity? I'll give you a moment just to think. What quantity do the triangles relate? What quantity is it? Well, they relate our velocity. So v final, there's v final y, and velocity in the x, because there's no initial and final in x. So we'll have to use some sort of triangle math. That means we need to find any two of these three to get theta, and then just use the appropriate trig function. So that'll be an inverse trig function. We can either find final, y, or x. Well, we're not given final, and as you might have noticed in the last problem, to get velocity final, we have to use v final y and vx. So let's just skip a couple steps and solve for these ones. So let's just solve for vx and v final y. So vx equals question mark, v final y equals question mark. So those are going to be our unknowns. I kind of put our givens over here. If you want, we can change these around. So the height, 2.19 meters, just write them up in the top. This v initial, is this going left to right or up and down? Well, it's going left and right. So v initial, that actually is our vx, 6.37 meters per second. Oh, all right. Well, we don't need to find that. Okay. Here's where it gets a little bit trickier, just to figure out what this all is. Because y-axis variables, in horizontal projectiles, there's always two y-axis variables we're given. We're given v naught y in horizontal projectiles, always 0 meters per second, because over here it's traveling left and right at first. It's not traveling up and down in the slightest. We're also given acceleration. Acceleration, negative 10 meters per second squared. Remember, because horizontal projectiles, I'm pretty much always going to make up and right are positive, always. So our height here, this is our displacement in the y-axis. So this actually is going to be negative 2.9 meters because it starts high and it ends low. So our height, negative 2.19 meters because it starts high and it ends low. All right. So now using our motion equations here, we have v final, v initial, acceleration, and height. Remember, height is analogous to distance. It's just for the other axis. So is there an equation that relates these four variables to find v final y? Yes, there is. I'll let you find it. I'll let you plug it in. But then you'll get v final y, you'll get v final x. This is opposite over adjacent. So tangent of theta is opposite over adjacent. All right, so you're going to have to use inverse tangent because we're looking for the angle. Make sure your calculator's in degrees. All right, if you have any questions, definitely let me know. That concludes this video for how to approach these problems. All right, see you in class.